Good day, class. This is Ma'am Cha. Our topic for today is all about definition of hyperbola. Our objectives are define what hyperbola is and graph an equation of hyperbola with center at 0, 0. Now, let's define first what is hyperbola. Hyperbola is a set of all points in a plane such that the difference of its distance from two fixed points is constant. It has two types. First, we have horizontal transverse axis, and the second one is the vertical transverse axis. Horizontal transverse axis, the vertex lies on x-axis, while the vertical transverse axis, the vertex lies on y-axis. Now let's proceed to our next definition. Vertices. The vertices are points in the hyperbola collinear with the center and foci. Each vertex is a unit away from the center. As you can see here in our figure, our center is at 0, 0, and the vertices is a units away from it. As you can see, hyperbola has two vertices. Unlike the parabola, it has only one vertex. Here in hyperbola, the horizontal transverse axis, the vertex or the coordinate of the vertex are positive or negative a and 0, while the vertex of the vertical transverse axis is 0, positive or negative a. Now let's proceed to our next definition. Foci. The foci are c units away from the center for any point on the hyperbola. The absolute value of the difference of its distances from the foci is 2a. As you can see here in our figure, our horizontal transverse axis, the focus are positive or negative c, 0, while the vertical transverse axis, it is 0 and positive and negative c. Now let's have asymptotes. Asymptotes intersect at the center of the hyperbola. A hyperbola approaches its asymptotes but will never intersect them. So now let's check where is the position of our asymptotes in hyperbola. As you can see here in our figure, our asymptotes are two lines intersect at one point. This point is our center, and these two lines or this asymptote doesn't touch or doesn't intersect with our hyperbola. Now let's talk about transverse axis. So transverse axis, endpoints of a segment of the vertices. So let's take a look the figure. Where is it located? Now you can see here in our figure, our transverse axis is a line segment who connects our two vertices. This line segment in ellipse, we call it major axis. But in hyperbola, we call it transverse axis. Now let's discuss the other axis that has a role also in hyperbola. Let's have conjugate axis. Conjugate axis is perpendicular to the transverse axis at the center. This axis has no common points in our hyperbola. Take note that to determine our vertices, we need to find A. And to determine the conjugate axis, we need to find the value of B. Now let's proceed to the other axis. Now let's talk about the focal axis or principal axis. The axis that contains the foci, the center, and the vertices of the hyperbola. So let's take a look. As you can see here in this figure, the orange line represents our focal axis or the principal axis. It is passing through our foci, the vertices, and also the center of our hyperbola. Let's have example number 1. We have x squared over 16 minus y squared over 9 is equal to 1. Find the following. So we're going to find the center, the vertices and points of the conjugate axis, the foci, the asymptotes, eccentricity, and equation of directrices. Okay, so as you can see, x squared comes first. So we're going to use the horizontal transverse axis equation. So that equation is x squared over a squared minus y squared over b squared is equal to 1, where c is equal to the square root of the sum of a squared and b squared, and c is greater than a. So first we need to find the value of our a, b, c. Okay, so first, let's rewrite. So the value of our a squared is equal to 16. Our b squared is equal to 9. When you get the square root of these two, so your a now, the square root of 16 is equal to 4. Your square root of 9 is equal to 3. Now we're going to find the value of c. So we're going to use this one. Okay, so c is equal to the square root of a squared. So our a squared is 16 plus our b squared is equal to 9. So c is equal to the square root of 25. Square root of 25 is 5. So the value of our value of letter c is 5. Okay, so now we already have a value of a, b, and c. So now we can easily now substitute those value here in our equations. So first, let's have the center. So our center is in the origin, which is 0, 0. So let's put the coordinates. We have 0, 0. So for the vertices, we have positive or negative, a, and 0. So our a is 4. So it is 1 positive and 1 negative. So this is our vertices. So 4, 0, and then negative 4 and 0. Next, our foci. So our foci is, the endpoints of our conjugate axis first is 0, positive or negative b. So our b is 3. So let's rewrite it here. 0, 1 positive. So our b is 3. The other one is negative. So our coordinates, it's 0, 3 and 0, negative 3 for the endpoints of our conjugate axis. Now for the foci. For the foci, so it is positive or negative c, 0. So our c is 5. So 1 positive and 1 negative. So our coordinates are 5, 0, and negative 5 and 0 for our foci. Next, for our asymptotes. So for our asymptotes, we have y is equal to positive or negative 5 over a and x. So let's rewrite it here. So y is equal to positive or negative b over ax. So y is equal to 1 positive. First, the positive 1. Our b is 3. Let's substitute. Then our a is 4. So we have y is equal to 3/4 x. And the other one is y is equal to negative 3/4. So this is our asymptotes. And now let's solve for eccentricity. So eccentricity is E is equal to C over A. Now let's solve for the eccentricity. Okay, so let's substitute the value. So our eccentricity is equal to C is equal to 5 over A, which is 4. So our eccentricity is 5 divided by 4 is equal to 1.25. So this is our eccentricity or distance. So let's rewrite it here, 1.25. Now, we're going to find the equation of the directrices. So our directrices, so for directrices is equal to x is equal to positive and negative a squared over c. So let's rewrite it here. So x is equal to positive or negative a squared over c. Now let's let's substitute the value. Okay, so x is equal to 1 positive. So our a squared is equal to 16 and our c is equal to 5. Then the other one, x is equal to negative 16 over 5. Then let's find out the simplest form. So, and now the simplest form is x is equal to 3.2 and the other one is negative 3.2. So let's rewrite it here. So x is equal to positive 3.2 and the other one is x is equal to negative 3.2. Okay, now let's graph the given points. First, we have the center. So our center is 0, 0. So our point is here. Next, our vertices. We have 4, 0. So it's here. This is our vertex. And the other one is negative 4, 0. So this is the other vertex. Next, let's plot the endpoints of the conjugate axis. So the endpoints of the conjugate axis is at 0, 3. So it's here. And then the other one is 0, negative 3. So it's here. Next, our focus or the foci. So our focus is at 5, positive 5, 0, and negative 5, 0. So our focus is here. So this is our focus. And the other one is here. Okay. Now, let's make a box connected with our conjugate endpoints of our conjugate axis. Connected also in our vertices. So let me show you how. So here we were going to make a box connected to our vertex. Also here. Okay. Here also. Okay. There you go. Wow. Okay, so as you can see here, we already have the box. So each corner, okay, it will the asymptotes, okay, the asymptotes will pass through our or intersect to our center. So how we're going to plot the asymptotes? So that's why this box is very important. It will tell you how far or how near to um, our asymptotes. So for our asymptotes, from corner, we're going to draw a line passing through our center going to other corner. So this is the one of our asymptotes, and the other one is here. Okay. Now, there you go. Now we're going to draw the hyperbola. So our hyperbola, okay, just like in parabola, the focus is inside the curve. Okay? And take note, hyperbola and asymptotes doesn't intersect or doesn't meet. Okay? It will getting closer but it will not intersect. Okay? So for this one, this is our hyperbola and this is our hyperbola. Sorry. The drawing is a little bit off. Okay? So that's it. That's how we're going to plot the points of the hyperbola. So let's have another example. Now let's have another example. Example number 2, we have y squared over 25 minus x squared over 16 is equal to 1. We need to find the following. We have the center, the vertices, endpoints of conjugate axis, the foci, asymptotes, eccentricity, and equation of the directrices. Okay, so for this equation, our center is at 0, 0 or at the origin. So let's put it here. Okay, now since y squared is comes first, we're going to use the vertical transverse axis equation. So this is the vertical transverse axis equation. So we have y squared is equal, y squared over a squared minus x squared over b squared is equal to 1, where c is equal to the sum of the square root of a squared and b squared. And c is greater than a. So first, we need to find the value of a, b, and c. So first, let's rewrite. So a squared is equal to 25 and our b squared is equal to 16. Once you get the square root of these two, so the square root of 25 is 5. The square root of 16 is equal to 4. And we're going to find the value of c. Okay, let's use this equation. So c is equal to the square root of 25 plus 16. So 25 plus 16 is equal to 41. So c is equal to the square root of 41. So square root of 41 is approximately at 6.4. So RC is approximately at 6.4. So that's the value of our C. Now we can also we already have the value of A, B, and C. So we can easily identify the coordinates of the vertices, the foci, and points of the conjugate axis, the asymptotes, eccentricity, and equation of directrices. So first we have the vertices. So our vertices is A positive or negative a. So our a is 5. So let's rewrite it here. So 0, 1 positive, and the other one is negative. So our coordinates, we have 0, 5, and 0, negative 5 for our vertices. Next, we have the endpoints of our conjugate axis. Our conjugate axis is positive or negative b and 0. So our b is equal to 4. So let's rewrite it here. 1 positive and 1 negative. So we have the coordinates 4, 0, negative, and negative 4, 0. Next, let's have the foci. For the foci, 0, positive, and negative c. So our c is approximately 6.4. Okay, so let's rewrite it. So 0, 1 positive, and the other one is negative. So our foci now is 0, 6.4, and 0, negative 6.4. Now, the asymptotes. Our asymptotes is equal to y is equal to positive or negative a over b x. Okay, so let's rewrite it here. So y is equal to positive or negative ab x. Okay, so first, let's substitute the values. Value of a is 5. The value of b is 4. So we have y is equal to 5 over 4x. And then the other one is y is equal to negative 5 over 4x. Or in simplest form, we have y is equal to 1.25x, and the other one is y is equal to negative 1.25x. So let's rewrite it here. Y is equal to 1.25x, and the other one is y is equal to negative 1.25x. Now let's proceed for eccentricity. So eccentricity, we have E for eccentricity, C over A. So let's substitute the value. So the value of of C is 6.4, and the value of A is 5. So our eccentricity now, so 6.4 divided by 5, we have 1.28. So our eccentricity is 1.28. Now, for the last one, we have the equation of directrices. So our directrices is y is equal to positive or negative a squared over c. So let's rewrite it here. Y is equal to positive or negative a squared over c. So let's substitute the value. So we have y is equal to positive 25 over c, which is 6.4. And the other one is y negative 25 over 6.4. So the simplest form, so 25 divided by 6.4 is equal to y is equal to 3.91 positive, and the other one is negative 3.91. Now, let's graph the given points. So, first, we have the center. So our center is at 0, 0, so it's here. Next is our vertices. So, we have 0, 5, and 0, negative 5. So, it's here. So, this is our vertex. Next, our endpoints of conjugate axis. So our endpoints is at 4, 0, positive 4, 0, and negative 4, 0. So positive 4, 0 is here, negative 4, 0 is here. Now, let's make a box connected to our vertices before we proceed to our plotting the foci. Okay, so let's make a box. Okay, let's connect it with our conjugate axis together with our vertices. Okay, so it's here. Okay, now let's plot the points of the foci. So our foci is equal to 6.4, yes, positive 6.4 and negative 6.4. So 0, 6.4, it's here. The other one is here. Okay, so this is our focus. Okay, now let's draw the asymptotes. Okay, so our asymptotes, again, like I've said a while ago, from the previous examples, we're going to connect the edge from the box edge center, then the other edge, the other one edge of the box, passing through the center, going through the other edge of your hyperbola. Next, let's graph or let's draw the hyperbola. So our hyperbola is here. Again, hyperbola and the asymptotes will never meet. So that's all for today. Thank you.